13.8 billion years ago, everything began. Space, time, matter, light. From a state beyond imagination, the universe burst into existence. Yet for almost all of human history, those first moments remained hidden, sealed behind an ancient cosmic fog. No telescope could pierce it, no theory could fully explain it. Until now. With the opening of NASA's James Webb Space Telescope, the universe has begun to reveal its deepest secrets. And with the detection of one tiny, brilliant galaxy, Webb has pushed the boundary of the observable universe closer to the Big Bang than ever before, rewriting the opening chapter of cosmic history. To understand what Webb has achieved, we must begin with where it lives. Unlike the Hubble Space Telescope, which orbits a few hundred miles above Earth, Webb resides far beyond our planet's gravitational shelter, nearly 1.5 million kilometers away. There, it orbits the Sun at a location known as the second Sun-Earth Lagrange point, or L2. At this delicate gravitational balance, Webb moves in lockstep with Earth, maintaining perfect alignment as both orbit the Sun. This positioning allows its enormous 5-layer sun shield to permanently block heat and light from the Sun, Earth, and Moon, plunging its instruments into a deep, stable cold. And in that cold silence, Webb listens. It traces the faintest whispers of infrared light, the stretched remnants of radiation released billions of years ago, at the dawn of cosmic time. Because the universe has been expanding since the Big Bang, that ancient light has been pulled into longer wavelengths, shifted deep into the infrared. Only Webb is sensitive enough to detect it. In a very real sense, Webb was placed here so it could hear the echoes of creation itself. Those echoes led to one of the most astonishing discoveries in modern astronomy, a galaxy known as MOMSI 14. This tiny speck of light appears as it existed just 280 million years after the Big Bang, when the universe was less than 2% of its current age. Its light has traveled for nearly 13.5 billion years to reach us. That makes MOMSI 14 the most distant galaxy ever confirmed. Webb's near-infrared spectrograph measured its redshift at 14.44, shattering previous distance records. Spectral fingerprints, especially a sharp Lyman alpha break, left no room for doubt. Humanity had, for the first time, crossed into the era when the very first galaxies were being born. And what Webb found there was utterly unexpected. Astronomers had long believed the early universe was quiet and primitive, a slow, dim place where galaxies emerged gradually. Instead, Webb revealed a cosmos already teeming with light. Bright galaxies were everywhere. In fact, these early galaxies appear to be nearly 100 times more abundant than theoretical models predicted. The cosmic dawn, it turns out, was not a gentle sunrise. It was an explosion of brilliance. As MIT astrophysicist Rohan Naidu put it, with Webb, we are seeing farther than humans ever have before, and it looks nothing like what we predicted. The implication is profound. Galaxies formed faster, stars ignited sooner, and cosmic structures assembled far more efficiently than we believed possible. One of the biggest surprises came from chemistry. MOMSI 14 contains unusually high amounts of nitrogen, far more than expected for a galaxy so young. In today's universe, significant nitrogen production requires multiple generations of stars living and dying. But MOMSI 14 existed too early for that. This suggests something extraordinary. The first stars may have been vastly more massive than anything that exists today. These supermassive stars would have lived fast, burned hot, and died violently, forging heavy elements in mere millions of years. Though such stars vanished long ago, their chemical fingerprints may still survive, etched into ancient stars in our own Milky Way. In that way, Webb is not only observing the earliest galaxies, but uncovering the ancestral history of our own cosmic origins. This is archaeology on the grandest possible scale. MOMSI 14 also sheds light on one of the most important transformations in cosmic history, reionization. After the Big Bang, the universe spent hundreds of millions of years filled with neutral hydrogen, a thick fog that trapped ultraviolet light. Only when the first stars and galaxies ignited did this fog begin to clear. Webb now sees evidence that MOMZ-14 is actively carving out a transparent bubble around itself, ionizing the gas and allowing light to escape. This suggests that reionization may have begun much earlier and far more unevenly than scientists once believed. The early universe, it seems, was not smoothly awakening. It was flickering. Before Webb, astronomers had glimpses of what might lie ahead. In 2016, Hubble detected a distant galaxy called GN-Z11, visible just 400 million years after the Big Bang. It was an extraordinary achievement, pushing Hubble to its absolute limits. But Webb went far beyond. MOMZ-14 reaches 120 million years deeper into cosmic time, a leap equivalent to rewriting entire chapters of cosmic history. And it likely won't stop there. Already, Webb has identified galaxies even closer to the Big Bang, waiting for spectroscopic confirmation. Each new detection presses humanity nearer to the moment when the very first stars ignited. These discoveries force a fundamental question. Do we need to rethink our understanding of the universe? So far, the core framework of cosmology appears intact, but the astrophysics, the details of how gas collapsed, stars formed, and galaxies assembled, may need major revision. The early universe was not slow. It was fast, violent, efficient. It built complex structures at breathtaking speed, defying long-held assumptions. And Webb is only the beginning. Soon, it will be joined by NASA's Nancy Grace Roman Space Telescope, a wide-field surveyor capable of mapping enormous swaths of the early universe. Where Webb sees with precision, Roman will see with scale, identifying thousands of primordial galaxies for Webb to examine in detail. Together, they will chart humanity's deepest journey yet into cosmic time. It took nearly 14 billion years for the light of MOMZ-14 to reach us.
During that journey, stars were born and died. Galaxies merged and shattered. Planets formed. Life emerged. Civilizations rose. And now, at last, that ancient light falls upon Webb's golden mirrors, carrying with it the story of the universe's first attempt at creation. For the first time, humanity is not merely imagining cosmic dawn. We are witnessing it. The fog is lifting. The darkness is breaking. The first light is returning. And this is only the beginning.